MIDI, which stands for Musical Instrument Digital Interface, control surfaces can be used for a wide variety of music production procedures. Samplers, virtual instruments, recorded audio, and synthesizers can all be manipulated with this device. In my own practice, I have used rotary knobs to input automation data into my tracks. This 6-slider control surface I have built will now allow me to more naturally and easily write volume, panning, and plugin parameters into my Logic Pro 10 projects. The materials I used were 6 sliding potentiometers, 6 560 ohm resistors, some jumper wires, a breadboard, the Arduino Uno, a sheet of plywood, a soldering station, solder wire, solder flux, a wood chisel, hammer, and other hand tools, wood glue, and various power tools such as a sander. My 6 potentiometers are connected to the analog input pins ranging from A0 to A5 on the Arduino. They are also connected directly to the ground rail on the breadboard. The 5-volt wire is connected to a 560 ohm resistor. Wires were stripped on one end and soldered to the potentiometer pins in order for the sliders to fit into the breadboard. I have color-coded the wires. Red is the 5-volt pin, green is the ground pin, and white signifies the analog input pin. The enclosure is made of half-inch thick plywood. Wood was chosen over plastic and other materials due to its durability. It was also selected because it is relatively easy to work with. I first cut the pieces of wood using a skill saw into dimensions I had previously sketched out. Then I proceeded to sand the pieces using an electric sander. The most difficult and time-consuming aspect of the enclosure's construction was having to chisel out by hand 6 1-centimeter deep indentations into the top plate. This is where the potentiometers are placed. Some holes were drilled above these indentations for the LEDs to be put in the future. Finally, wood glue was used to adhere the various wood pieces together. All these programs communicate with one another for the control surface to work. The hairless MIDI to serial bridge, Arduino MIDI library, a digital audio workstation, I'm using Logic Pro 10, the Arduino IDE, an audio MIDI setup, which is built into the Mac operating system. This code, originally created by Starfire Tech in 2009, was modified to include 3 more potentiometers. The lengthy code was simplified and shortened using an array and for loop. In order to use this control surface, upload the code to the Arduino. After you have uploaded the code to the Arduino, ensure that the device is recognized and online in Audio MIDI setup, like so. The IAC driver should be highlighted, and the Devices Online box should be checked. Open the Hairless MIDI to Serial Bridge program and select the correct serial port, MIDI in, and MIDI out options from the drop-down menu. When all is communicating well, the green lights will flash in the program. Finally, open your Logic Pro 10 project and add or install the control surface. Control surfaces and setup. Here you can do so. I have already had it installed and it comes up as recording light. You can then map the sliders with key commands like Command L or by going to Controller Assignments. Here. Now it's time for a little demonstration. By moving the slider up and down on the control surface, I will increase and decrease the volume of the deep downtown drum beat track, and these changes will be written into the program. I apologize in advance for the distorted clipping sound. As you can see, there is an odd, quick oscillation in the automation. There are several reasons why this disturbance could be occurring. First, there is a possibility that the wires are faulty as I used a mixture of aluminum and copper wires. Some wires are a thinner gauge than others and may not be making a full connection. Some sort of interference between the potentiometers could also be to blame, as when I was testing one at a time, this issue did not occur as much. Finally, perhaps there's an issue somewhere in the software communication. I think this because I have found that Hairless MIDI to Serial occasionally closes or stops reading, and I sort of have to keep an eye on it while recording. Though not working absolutely perfectly, this control surface is able to successfully communicate with Logic Pro and write automation data. It has taught me much about MIDI communication, control surface hardware, using MIDI within the Arduino IDE, among many other things. I will likely continue to work on getting rid of the bugs in this project, as well as adding some LEDs to it in the future.